Assalamualaikum and hi. Okay, so now we look another section which is part of the vector valued function. So last time you have learned a bit about how to sketch the graph for the vector function, and so you have looked at some application which are related to the vector valued function. So now we want to have another important thing, which is the continuation from the vector value function. So but I have to introduce something first, which is about the scalar field and vector field. Okay, because the next application, you have to deal with this both particular field. So what is the I start with the scalar field. Okay, scalar field is something that just you can evaluate the magnitude. You cannot have the direction. Okay, for example, speed, but velocity you can have the direction and also the magnitude, right? But speed is just magnitude of the velocity. You can have the magnitude or the value, but you don't have the direction. Okay, so other than that, you can have many things which is related to the scalar field, but this one is more general. So scalar field in 3D, which is you have x, y, z, is an assignment of a number, okay, number value at specific t on a specific point. Okay, so meaning that last time you have just a function where let's say you have in method 2 you have learned about a lot about the multivariable. So that function is just depends on x, y. Yeah, that is just a value, nothing to do with the vector. But now the extension of the scalar field, you instead of you know the point at specific x, y, z, you also they also depends on the at some specific time. Okay, so then now we add another parameter, which is t. And so for example, we have a temperature. So temperature t, where the function is depends on the x, y, z, but x, y, and z, they are depending on the t. Okay, and similarly pressure also scalar. They don't have the specific direction. So p, pressure, maybe depends on the x, y, z. Also x, y, and z are depending on the parameter t. Okay, so now in general, a scalar field is simply a scalar quantity, don't have a direction. It is a function of space and time. Okay, if you have a scalar, just scalar, one single value, let's say at specific t, so you put t equal to 1 or t equal to 0 into the x, y, z, so you just have a one scalar, one single value. But then the combination of the very many t or on the some interval, so you can have a scalar field. I would say that scalar field is the very many point for very many specific time. Okay. We also have density, for example. Density also considered as a scalar field, where the density depends on x, y, z, but x, y, z are depending on the specific t. Okay, so that is a scalar field. So actually for this course, we don't really focusing on the scalar field. We just apply a bit. So I will show you after this when we have the scalar field or scalar function. Okay. And another example. So for example, this is a scalar field. So what's my pencil? Sorry. Okay, for example, you have this is a combination of very many points. Okay, very many points. So there is this okay, let's say this is a point. Okay, this is a point for x, y, z and t equal to 1, for example. And this one, the value of x, y, z at t equal to 2. And this one is a point, so you have another point here, you have another point, you have another very many points. So this one is actually the x, y, z for some specific t. Okay, so these are example of scalar field, very many points for different t. Okay, so this one, the combination of all this referring to the temperature near the heated wall. So the more darker the region, so meaning that you have the higher the temperature is. Okay, so now we want to talk about the vector field. Okay, so the vector field is something have extra where we know that vector field you can have the magnitude and also the direction. Okay, so again, vector is just a vector is just a one vector. Okay, for some specific x, y, z and specific t. But if you have a very many vector for different t, so it is called vector field. Okay, for example, velocity. So the velocity for z is the function of xy. So you have the point of x, y, z, and that is a single point. But because of they are depending on t, so for a single t, so you have a vector. But if you have very many t for some interval, so you can have very many points. So that is called vector field. And other than that, we have a magnetic field, also force field, acceleration, velocity, and so on. Okay. So the formal definition of vector field in 3D, just like the scalar field just now, but now the representation of the vector field, you have to put capital F, or you can put this arrow, okay, or something curly down here. So a vector field is simply a vector quantity that is a function of space and time. Okay, so if you have okay, this is for a vector field for some value of x, y, z and for some specific t. But if you have a vector, which is a one single vector, so that is for the specific t, only one t. Okay, so the combination of the very many vectors for specific t, so you call that as a vector field. So vector field is a distribution of vectors in space and time, okay, for some interval t. So a vector field is normally given by given in vector value function. Okay, so last time we have normally we use the r, right, vector r. So now we use the f. So it depends if you're talking about the curve. Okay, so the curve is one of the example. Okay, now we have a vector field, so normally it's denoted by the vector value function as well. Okay, so now you can see that. So you have the equation here is in terms of x, y. Okay, so now you choose for the some specific value of x and y, so you can find out the some vectors here. Okay, so what I mean here is you substitute, you choose a point x and y. Let's say x equal to 0 and y equal to pi, for example, or y equal to 4, for example, and then you substitute that number into this x component, okay, and also into y component. So you will get a position vector, right? You will get a vector. So then you plot that vector where it is from the point that you choose. So when you draw, when you plot, remember I teach you how to sketch the vector from the position that you have. So you choose a point. Just now I said that x0, y4. So at point of 0, 4, then you can determine the direction of that arrow. Okay, so now for the combination of all the point of x and y, you can have this pattern. Okay, so this case, if you relate this with the sketching of the graph of vector function, so for this one, it is complicated to be done, right? You cannot, it is impossible for you to sketch the graph on 2D, the graph for the vector function. As I mentioned before, if your function is 2D and it's depend on xy, so you have a graph supposed to be a curve because you have 2D here, but that one is impossible to be done because if you just assume x, okay, this one x equal to sine x cos y and then y equal to cos x, so do you think it is easy to be sketched? So that's why we just assign a number, just look at the output. You substitute the x and y and then we just plot the depends on the output of the vector function. Okay, so I will show you how to sketch from this. So these are given and this is a bit tedious to be done by hand. Now maybe you can get some idea from this example. So now we are going to sketch the vector field of this particular vector field. I mean, sketch the vector field of this given vector function. So if you try to put the thing that you've done before this, where you assume that you have the component x is equal to minus y and the component y is equal to x, then you just stuck to sketch the graph of this vector value function. But then now we want to plot the output vector. Okay, so we are going to put the to plot the output vector where you choose any point. So the input is just select randomly the x and y, and then you evaluate the output vector. Okay, you will get a vector. And then if you, let's say you choose 10 input value of x and y, 10 point, so they will have a 10 arrow. Supposedly they should have a 10 arrow, and then we plot on the xy plane. Okay, so for this, maybe so we start with the, maybe we want to select so let's say we want to have so at the point 0, 1 and all 1, 0, so the output vector at the point of 1, 0. So then you evaluate. So you have this one, the x component will give you 0, and then for the y component you will got 1. So that is your output value. Okay, for the x for this that we assign at 1, 0, so your vector is 0, 1. Okay, now we go to the, so we sketch later. So just choose we assign the x and y, and then when you put into the vector function here, so you will have minus y, so you will get minus 1, and then x0. Okay, and maybe you choose another vector f at, let's say I'm choosing 3/2 minus 2. So when you substitute, so you got 2 and then 3/2. Okay, then we choose another point, the input vector. So we have minus 1, 2. So what is the output vector then? So minus 2 and that's minus 1. Maybe we choose another input vector, 3, 4. So minus 4, 3. Okay, so that is the input and the input vector, and we'll give you the output. Now we want to plot this output vector so that we can have the vector field. Okay, instead of we have a graph, so now we want to plot the vector field. So now you have more than one vectors, right, for specific value of x and y. Okay, so now you need to have the scale. Okay, so let's say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so now add 1, 0. So x1, y0. So your point is here. Okay, so where is your arrow? The direction of the arrow. So remember, I teach you, if you want to plot the position at 0, 1, I mean the vector at 0, 1, you cannot just directly put the 0, 1 from here, where you assume that you start from the origin, but you are starting from 1, 0. So to plot, so in order to plot, you have to consider, you have to add. So 1, 0, 1 plus 0, 0 plus 1. So your point here is at 1, 1. So where is 1, 1? So 1, 1 is here. So now you draw the arrow. Okay, so that is your first vector at 1, 0. So now we move to the 0, 1. So 0, 1, then you are here. Okay, so now to plot, you have to add both points. So you will have minus 1, 1. Okay, so minus 1, 1, then that is your point. So you are pointing that way, right? Minus 1, 1. Okay, and then at 1.5 minus 2. 1.5 minus 2 here. Okay, so that is 1.5 minus 2, 1.5. This one. Okay, and where is the point that you have to, what is the direction of your arrow? So you have to add both points. So you have 3 over 2 plus 2, and then minus 2 plus 3. Is this correct? Yeah, 3 over 2 over 2. And this will give you so the point now become 3.5, and then this one become negative 0.5, right? So 3.5, 3.5 negative. So 3.5, this one. So that is your direction. Okay. And next is negative 1, 2. Minus 1, 2. You are here. So to plot, then you have to add. Got minus 3, 1. Minus 3. 1, 2, 3, 1. Here. So that is your direction. Okay. And then at 3, 4. 3, 4, 3, 3, and then 4. 1, 2, 3, 4. 3. Somewhere here. So where is your direction? So to plot, you have to add. So you have minus 1, 7. So minus 1, 7. So 1, 2, 3, 4, 5, 6, 7 minus 1. So that is your direction. Okay, so you can see that some they have a different length of the arrow. It depends on the magnitude of your vector. Okay, so these are examples. So if you have a very many points, then you can see the pattern of that vector field. Okay. Okay, so if you continue plot for several point, the several input point, then will give you the output vector. So you can have this combination, or if you use the software, so you can see that the vector field is in this way. So it's just circling around and around and around. Okay, just like something irrotational. No, it is rotation, right? But not, there is no sync point or source point. So you will know what is mean by the source point or sync point after this. Okay, you can see that it's just circling around the origin. Okay, so this is an example for the vector field for this one. Okay, so here now it's something different with the graph sketching. This is nothing to do with graph. So we just plot the output vector based on the input point, the input value of x and y, and then we just plot for very many arrows. So that is called vector field. Okay, so to show you the vector field for that example that we discussed. So here I'm just using Desmos. So just Google vector field plotter, and you will see that there is a Desmos in the list, and then just plug in the function provided, and you can see that this is the vector field. It's just circling around the origin.